Sky is so high, if you don't know how to fly, Aimfill is here to make you fly. Sky is so high, if you don't know how to fly, Aimfill is here to make you fly. Here we go.
Freedoms of air. Yesterday our portion we covered was freedoms of air. So can anyone tell me
Rise
what
over
is
the
the
sky.
first freedom of air? Did you all guys get the notes that I sent?
No, sir.
Sent. One second.
I didn't get.
One second. One second. Okay. So I did send. So that's fine. So you guys have any doubt regarding freedoms of air? I'd like to know that first before I continue, because this will be the most important part that you need to learn in the air regulations. That is in your subject air regulations. So you guys have any doubt regarding freedoms of air? Any of the freedoms of air or any point that that you didn't understand?
So fifth one.
Yeah, go ahead, go ahead. Do you have any doubts?
Excuse me, sir. Excuse me, sir.
Yeah, go ahead, go ahead.
So, is it possible for you can that you make a revise of that all the freedoms of air?
What I didn't
Is it
get you.
possible for you? Is it possible for you that you can make a revision of this freedom of air?
Freedom of air. You want me to revise, take this topic once again?
Yes, sir.
Okay then.
Yes, sir.
Okay. Okay then. So freedoms of air. So freedoms of air. The reason freedoms of air came is it's a bilateral or a multilateral agreement signed and approved between two or more states. That is, it is the permission given by one country to another to use their airspace. So it can be a mixture of that is, if two countries or two or more countries are involved just to initiate their schedule of service, two or more states sign up into an agreement that this particular country's airline is allowed to use our airspace for revenue purpose. And this will be also authorized and sanctioned by their particular military or security bases. So for total in freedoms of air, we have total 9 freedoms of air. And for this, we have taken examples from 3 countries, that is India, UAE, and New Zealand. So based on these 3 countries, I will be presenting the examples so that you could understand. So you guys know which airline is working for these 3 countries? Any idea? That is, I'm talking about the national carrier. So, do you know the national carrier of India, New Zealand, and UAE, United Arab Emirates?
Air India,
Air India, Air New Zealand,
Air New Zealand, okay. What about UAE?
Etihad, and
Okay,
Emirates.
Etihad. Yeah, so Etihad will be for UAE, Air India will be for Air India, Air India will be for India, and Air New Zealand will be for New Zealand. So, the first freedom of air, the right to fly over a foreign country without landing. That means a country is authorizing another country for their airlines to fly over or use their airspace to cross only, and no landing permission will be given. So, in this example, you can see that Etihad Airways is operating a flight from UAE's national capital, Abu Dhabi, to New Zealand. Say you could put it at Auckland. So, a flight from Abu Dhabi to Auckland operated by Etihad Airways is flying above UAE, flying above India with the permission. So the first freedom of air is that UAE, India, and New Zealand has come into a bilateral agreement that Etihad Airlines can operate their flight and they can use the airspace of these three countries. That is the first freedom of air. That is, the aircraft is not allowed to land in India, but it can use its airspace. This is the first freedom of air. The second freedom of air is the right to refuel or carry out maintenance in a foreign country without embarking or disembarking passengers or cargo. So we'll take the same example, that is Etihad Airways is operating from Abu Dhabi to Auckland, but India has granted them permission to land only for technical reasons, that is either fueling or maintenance. They are allowed to land and finish up their maintenance procedures and move on. So no passenger embarkation or no cargo embarkation will be allowed. That is no revenue generation for Etihad from Indian side. So this is the second freedom of air. Third freedom of air, that is the right to fly from one's own country to another country. So Etihad, that is UAE and India will have a contract that Etihad can take passengers from UAE and come to India. So it's a revenue generated for UAE. And the fourth freedom will be the same opposite. That is, Etihad Airways is allowed to uh, take passengers from India to their own country. So this third and fourth freedom is clear, right?
Yes, sir.
Okay. So next is the fifth freedom, the right to fly between two foreign countries on a flight originating or ending in one's own country. That is, the three countries will come to agreement that Etihad Airways is allowed to do operations from India to New Zealand. So Etihad Airways is given operation to do their service sector from India, say from New Delhi to Auckland and back to New Delhi. But since the aircraft is from UAE, the aircraft will operate from Abu Dhabi to New Delhi empty, that is ferry. Only the crew and the aircraft will be moving from Abu Dhabi to New Delhi, and they'll be operating their sectors between Delhi and Auckland. And once their sector and service is completed, the aircraft will disembark all passengers in New Delhi and travel back to their base empty-handed. That is, no passenger will be taken to Abu Dhabi. So no revenue for UAE, only revenue generation for India and New Zealand on the expenses of UAE. Is that clear?
Yes, sir.
Okay. Moving on, the sixth freedom. So the right to fly from a foreign country to another while stopping in one's own country for non-technical reasons. So in this case, uh, the example we have taken is between the same three countries, but this time it's Air India who will be operating its sector. That is, it's traveling from Abu Dhabi to Auckland with a non-technical. That is for maybe for fuel or maybe for any other purpose. It will be landing in New Delhi. Kilometers. Can you tell me which is the longest sector operated by the commercial airline? Which is the longest sector operated by an airline? Just give me the two city names.
Qatar to Auckland,
Sorry?
By Qatar Airways, I think. From
Any?
Doha to Auckland.
Dubai to Auckland.
Doha.
Doha to Auckland. Yes. Qatar Airways flight 777-200 LR operates a flight from Doha to Auckland. But the longest flight, Doha to Auckland, is 14,800 kilometers odd. But the longest flight is 15,148 kilometers operated by Singapore Airlines from Singapore to San Francisco. That is, it will be covering up the entire Pacific Ocean. So making a flight plan for such aircraft, is it easy or tough?
Sorry, sir, will you please repeat?
I'm asking you that a long sector aircraft, a flight from Singapore to San Francisco, how is it easy to make a flight plan for Singapore to San Francisco? Is it easy?
No, sir.
Why is it not easy? What
Because
makes
there
it?
will be refueling.
No, refueling is not required. 15,178 kilometers, single fueling, maybe about 140 tons of fuel on board the aircraft, and the aircraft can fly. So fueling is not a problem. What else issues comes?
The weather will change in.
Yes, whether there is a chance of weather change, anything else. Anything else. Something very important. Okay, don't just go too deep. It's the ATC towers. So you will not be having enough ATC towers when you're traveling over a sea, and you need to also check the tops condition of the aircraft, and also the uh, uh, commanders, that is the pilots, must also have the license of operating an ETOPS flight. So these are the things, when these all add up, when you cross an ocean, the flight plan becomes much more thick, and also you will have more complications regarding that particular sector. You will have very less ground-to-air communications. The aircraft need to maintain a steady visual flight rule, and lots of other problems charge up when the weather changes, because you know you're crossing Pacific Ocean. There's a chance of storm, or there's a chance of a tornado, or anything else, lightning. So these problems will create huge, and based on that, if you don't have the enough payload on the aircraft, or if you don't have enough fuel for the aircraft for that sector, that's going to create a lot of trouble. You can't just come back with that amount of fuel. So you need to always plan very deeply of how the sector goes whenever it's going, when you're crossing an ocean, or there's a flyover sea. So that's for the, so coming to our topic, narrow body and wide bodies. So narrow body, commonly also known as single aisle aircraft, which will have a single aisle permitting up to six separate seating in a cabin. That is below 4 meters. You need not learn about the 4 meters and all. It's about six abreast, three on each side of the aisle. And commonly seen types of passenger are, one is the Airbus family, the 320 family. Then we have the 737 family, uh, Dash 8, ATR, and Scandinavian 1900. So these are the examples of narrow body aircraft. This is the most commonly used aircraft now. We have two companies who manufacture the most the largest number of aircrafts. One is the Airbus, which is a complete electronic type, and then we have the Boeing, which is a hydraulic type of aircraft. So these two are the largest selling aircraft manufacturers in the world. Next, this is an example of one abreast seating, that is one seat on each side. The aircraft type is a Scandinavian 1900. Uh, you can see, have you ever seen private jets in movies or anywhere?
Yes, sir.
Yes, sir.
Yeah, so private jets, if it's for one single person, the interior would be completely different. In this case, it's being used as a aircraft for operation, that is for commercial purpose. So it will be having one seat per abreast, and the total length of the total seats in the aircraft will maybe say 20 seats, or maybe 25, or maybe 40 seats. That depends upon the length of the aircraft. This is one abreast seating. Then we have two abreast seating. These are normally flights, that is ATR type. ATR or Dash 8 aircrafts will have 2 seats abreast. This is also a complete commercial flight, but for a very short sector, that is short to medium, it can fly say about from Chennai to Coimbatore in 1 or 1.5 hours. So these type of aircrafts are for based on the requirement. So if you have very less passengers traveling, they'll adopt this kind of ATR or Dash 8 flights. Next, 6 separate seating. The standard commercial flights will have this kind of seating. That is Airbus 320 and Boeing 737. 6 abreast, capacity from 180, from 160 or 150 to all the way up to 220 seats. So this is the configuration. That is for Airbus 319. If you take, you can say about 140 odd seats will be there in an Airbus 319 if it's full economy. And for 320, you can go to 180 seats. If you're going for Airbus 321, you'll have more seats, maybe 210 or 220 seats on the aircraft. So this is the 6-seat abreast seating. Then hold configuration. So hold configuration, Airbus 320 will be having totally 2 holds, that is forward and aft, but it has total of 4 compartments, 1, 3, 4 and 5. So in Airbus 320, the forward hold will have compartment 1 and the aft hold will have compartment 3, 4 and 5. So can anyone tell me what is the maximum capacity in compartment 4?
kg.
Yeah, exactly. So it's 2110 kgs for compartment 4. What about compartment 1?
3,402.
Okay, good. So forward compartment will be 3402 and compartment 4 is 2110 kgs. Same way for Airbus 321, we'll be having same forward and aft will be having that is forward will be having an extra compartment, that is compartment 2. So forward will be compartment 1 and 2 and aft will be compartment 3, 4 and 5. And in the case of if you're going for an Airbus 319, that is a smaller version than 320, there will be only 3. That is forward hold will be having compartment 1 and aft hold will have only compartment 4 and 5. So 319 has compartment 1, 4 and 5. 320 will have compartment 1, 3, 4, 5 and Airbus 321 will have compartment 1, 2, 3, 4 and 5. Is that clear, guys?
Yes, sir.
Okay. So next is a wide body aircraft. So wide body aircraft is an aircraft with 2 aisles and will be much larger in size for uplift of maximum passengers. So the most commonly seen aircrafts are 340, 350 and 380 for Airbus side, and for Boeing it will be 777, 787 and 747. So this is a standard economy class in a wide body aircraft. As you can see that the configuration is 2, 4 and 2. We'll have 2 aisles on either side of the 4-seat abreast, that is on the 4 seat in the center. So we will have 2 aisles and the seating will be from 7 to 10. Next we have a 7-seating business class. Uh, this is normally for wide bodies, that is for the jumbos, that is Boeing 747 and Airbus 380s. So in those type of aircraft, you will have this kind of configurations. Yes, now for 777 787 and also for 330, 340, they are doing a conversion where the business class is being given of much more preference. That is, these kind of seats will be allotted for those passengers traveling in business class. First class, this is actually the Emirates first class for an Airbus 380. It's a individual cabin allotted for a single passenger, and maximum for Airbus 380 we will be having about 16 first class, and in the case of 777, you will have only 8 first class. So individual cabin will have a full stretched seat that can be used as a bed also. We'll have a TV, laptop, not laptop, TV and a tab. The food priorities will be different. You will have more service, and this probably will cost you something from Trivandrum to Dubai for these first class seats. It will cost something around 2 to 3 lakhs. Next is a 777 passenger flight lower deck configuration. In this, as you can see, we have totally 5 compartments, 2 holds and 5 compartments. First compartment will be having up to 4 containers positions, that is 11, 12, 13 and 14. And in those 4 container positions, you can fit at least 3 pallets. Whereas in compartment 2, you'll be having 8 cross sections. In that 16 containers you can load, or you can load 5 pallets. So this configuration will be based on the lock types, that is locks that we use. I'll take it in the next session. I need to move on to the next session. So that time I'll teach you about what kind of locks are available and all those points. So this is a 777 PAX flight's lower deck configuration, and the configuration of the flights I'll tell you later on. Next, 777 freighter. In this type, it's similar to the 777 PAX flights, but you will have cargo in the main deck. In passenger flights, you will have cargo in the lower deck. In a freighter, that is in cargo flights, you will have cargo both on the lower deck and also on the main deck. Next, we will move on to ULDs. So for today's session, we will take up to what are the types of ULDs, and we'll move on to we'll move on to the rules of air concept. So, contains what is a ULD? ULD is a container used to load luggage, freight, and mail on wide-body aircraft and specific narrow-body aircrafts. So, it allows preloading of cargo, confidence the containerized load will fit in the aircraft, and efficient planning of aircraft weight and balance, and reduce labor and time in loading aircraft holds compared with bulk loading single items of cargo or luggage by hand. So, a unit load device is a container. I'll show you the container types. So it's a container where you can load the baggage, cargo early enough so that before the aircraft comes, you can load it and keep it ready. And when the aircraft comes, you can just quickly load it into that particular position. So wide body aircrafts are easy to plan. So you only need to change the position of the cargo or position of the container to get a proper trim for the aircraft. So how do we identify? A ULD is normally a 10-letter code. As you can see, AKE12345EK. So AKE stands for the ULD type. That is what type of ULDs are used. What is the base dimensions, or what is the contour type. All those types will be seen. AKE stands for the ULD type. Then 1234 with the number will be the number allotted by the airline to identify the containers. So it will be easy for the load planner to plan the position of the containers. You will have the number, you put that into a particular position, and it's easy to load. EK, that will be the airline owner who is owning that particular containers or maybe ULDs. So types of ULD. So most common types of ULDs are LD3, LD6, LD7, LD9, PLA pallet, and P6P pallet. So what is LD3? Is this is LD3, and it is normally termed with the. So normally you can see that these kind of containers will have a coding called AKE. So these containers have a code called AKE, in which A, the alphabet A stands for standardized container. A means standardized container, that is, it's authorized and regulated by Gov and IATA. So A stands for authorized container. K will be the base dimension of the container. So in this case, for LD3, you will have a base dimension of 60.4 inches to 61.5 inches. So K stands for 60.4 into 61.5. That will be the base dimension. K stands for base dimension. Then we have E. So E1 is the height and the contour length. So the height of the container will be 64 inches and the contour length is 79 inches. As you can see that in the base you had seen 61.5 in one side and the contour length will be total 79. So this is for an LE3. The most common one is AKE. The commonly used one is AKE. Next we'll have LD6. So LD6 is a combination of two LD3s. It will be termed with the letter ALF. So A, as you all know, is standard container. L will be the base dimension, that is 60.4 into 125 inches. So you can ask me a question that two LD3 is one LD6. So LD3 we have the base of 61.5. If you add that to, you will have something called 123 inches. So where did the 2 extra inches go? Or how did the aircraft have an extra 2 inch? So the extra 2 inches is for the center guide, that is the lock position for these containers inside the aircraft. So 125 inches is, you will have 2 inches of lock and the remaining 61.5 for one container and another container will have 61.5. So totally you'll have 125 inches of base. So 60.4 will be, that is 125 inches will be facing the nose and 60.4 will be facing the dorsal. This is for LD6 and the commonly used codes are ALF. Next, LD7, it is also known as a P1P pallet or a PAJ pallet. So what LD7 is one, the normally used is PAG. So PAG stands, P is for standardized pallet. A will be the base dimension. In LD7 it is 88 into 125 and G is the height and the contour. So in this type of pallet, the height will be 64. That is the standard height inside the, that is the, for the lower deck aircrafts, the standard height is 64 inches. So the pallet stacking will also be done for 64 inches. And the contour, since the pallet doesn't have any contour, the entire length of the consignment. So it could be 125 or maybe 120, 120 or 123 inches, the contour side. And the commonly used pallets are PAG and PAJ. Next, LD9. This is a similar one. only thing it's closed. So LD9 will have pallets like AMP or AAP. So since it's LD9, it's AAP. That is, A is for standardized container, and A will be for the base contour, that is 80 into 125. Then P will be standing for the height and the contour length. So this P will have difference because the previous one I had said about G, that may be 120 or 123 maximum the contour length. But since this is a container and the base, and since it's a complete rectangular box, the base is 125, definitely the contour will also be 125 inches. That's why it has got the code AAP. P6P, it is similar to the AAP type, that is the P1P palette. Only thing, the base dimension will be 8 inches, 8 inches in width, that is extra 8 inches will be there. It will be 96 into 125. The height will be from 64 to 180. That is, these kind of pallets are used in cargo flights or to be loaded in the cabin side. That is the main deck. So is that clear? What regarding the ULDs? I'll send in these notes because you will not understand it just by me explaining. You can refer these notes. I'll send in the notes today. So for your test, what are the topics we are going to cover? All those details I will put it in the point of notes and send it to Nargisman, so you can collect it from them.